We've looked at a number of different types of conversion problems so far this semester. We haven't talked a whole lot about one of these properties of a material that tells us how much mass there is in a certain volume. And we call that value a density. Density will tell us normally, the way that density would be reported will tell us how many grams are in a milliliter. That's the way we normally observe or look or find densities that are reported in chemistry. So this problem asks us, we have this cube of gold. And this cube of gold happens to be 3 centimeters on a side, which means the height, the width, and the depth are all 3 centimeters. So remember, density tells us or allows us to convert between volume and mass. So if we knew what the volume of that cube would be, we could convert that volume to mass using the density of gold. Okay? So remember, this problem says that this is a gold cube, and we could determine what the area of a cube would be by taking the length times the width times the depth. In this case, it's 3 centimeters to a side, so it's 3 centimeters times 3 centimeters times 3 centimeters, or 27 cubic centimeters. All right. Now, if we were looking at significant figures here, all right, we would say that this area would only have one significant figure because each of those, the length, the width, and the depth, only have one significant figure. So remember how I talked about not rounding, but carrying the entire number forward, but keeping track? So remember that, because it's going to become important to us here in a second. All right, so what we want to do now is we want to take that volume, and you might say, how do you know that's a volume? Well, first of all, I wrote that this was an area. Of course, that's wrong. We were calculating the volume of that cube. So the volume of that cube was the length times the width times the depth. And whenever we have a volume unit, there are a couple different ways, or there's at least one way that I can think of that you might be able to tell whether it's a volume unit right away. One of those ways is just by knowing what a volume unit is. So we talked before about some standard units for volume. We said liter was that, so if it's milliliter or microliter or liter, we know right away that those are volume units. So that number that those are attached to must be a volume. The other way is that if you look at a unit and it's a cubic units generally, when it's cubic of a width unit, that's going to tell us that that is the volume based on that particular unit. So this is telling us this is the volume of that cube in cubic centimeters. So that cubic is telling us that that would be a volume. So 2 ways we could figure that out if we didn't know. And again, remember, this is not area, it is volume. I just screwed up as I was working through the problem. So I've got 27 cubic centimeters. Remember, I've got the 1 there for significant figures. Now what I want to do is I want to use the density of gold, and the density of gold is given as 19.4 grams per milliliter. And so I want to use that density to convert between those 27 cubic centimeters and the mass of that cube. Because remember, we were asked, what is the mass of a cube that is 3 centimeters to side if that cube is made of gold? Now, the first thing is, remember our density is 19.4 grams per milliliter. We do not have milliliters, so we have to find some way to go between cubic centimeters and milliliters. This all comes down to the 3 conversion factors that I told you about. Because we want to go between cubic centimeters and milliliters. And remember I told you that a cubic centimeter and a milliliter are exactly the same thing. By definition, those 2 things are exactly the same. So we know right away that we can get from cubic centimeters to milliliters, and in reality, you're going to get to the point where you may not even need to write this down on paper. You can do it in your head. That's perfectly fine. I will almost always write things like this out just because that's the way my brain works. I like to have it down on paper so that I can see it. Now the next step is, I've got milliliters. I want to end up with, or determine how many grams this particular cube would, how many grams of mass this particular cube would occupy. And so I said, or the problem told us, that there are 19.4 grams of gold in a milliliter. So now the milliliters would cross out, and I'd be left with grams. Notice how I did this. It is a number that has 2 units. All right, those units are divided, grams per milliliter. I put the grams on the top, the 19.4 grams on the top, and the milliliter on the bottom. That's the number of grams in exactly 1 milliliter. So now if I stop this problem, this conversion problem, I will know how many grams are in those 27 cubic centimeters in that cube of gold. So when you multiply this out, you end up with 523.8 grams. If we're looking at significant figures, now this one's exact. Remember, exact numbers or definitions, you can call it a definition, they don't affect the number of significant figures. So that's not going to determine how many significant figures our answer would have. Then we get to the density. The only portion here that we have that's a number is the 19.4. It has 3 significant figures. So I've got the 27 cubic centimeters that has 1 significant figure, the 19 before the 0.4 that has 3. So our answer should end up with 1 significant figure. So we are going to round to the 500ths place, to the hundredths place, and we end up with 500 grams. Particularly useful to be able to use density to convert between volume and mass. We will do that over and over again. In particular, you'll do that a lot in lab, but also some of the problems will be like this throughout the semester. So it's a good idea to get a handle on using density to be able to go back and forth between those 2 different units.